Hi there, my name is Jerry, the IT tutor and study coach at ITonlinelearning. Today we're going to take a look at IP addresses as well as TCP IP ports and protocols. So every machine on the internet has a unique number assigned to it called an IP address. Without a unique IP address on your device, you'll not be able to communicate with other devices, users, and computers on the internet. You can look at your IP address as if it were a telephone number, each number being unique and used to identify a way to reach you and only you. Now, there are two types of IP addresses that can be used on a network. The first, and the version that the internet and most routers are currently configured for, is IPv4. So this version uses 32-bit addresses, which limits the amount of addresses to around 4 billion possible unique addresses. Some of these addresses are also reserved for special purposes. Due to the growth of the internet, there has been concern that the pool of possible addresses would be exhausted in the near future. Now, with this in mind, a new version of IP addresses was developed called IPv6, or Internet Protocol version 6, that would change the address size from 32-bit address to 128 addresses. This change will allow for generous IP address allocations to networks, without any foreseeable problem with the amount of addresses available. In order to use IPv6 addresses, existing routers and hardware would need to be upgraded or configured to use this new version of IP addresses. As IPv4 is still the most commonly used, I'm mostly going to focus on that version of IP addresses. Now, an IP address always consists of 4 numbers separated by periods, with numbers having a possible range of 0 through 255. An example of how an IP address appears would be, let's say, 192.168.1.10. This representation of an IP address is called decimal notation and is what is generally used by humans to refer to an IP address for readability purposes. Now, with the ranges for each number being between 0 and 255, there are a total of 4,294,967,296 possible IP addresses, so quite a bit, as you can see. Now, out of these addresses, there are 3 special ranged that are reserved for special purposes. The first is the 0.0.0.0 address and refers to the default network, and the 255.255.255.255 address, which is called the broadcast address. Now, these addresses are used for routing, which is a completely different, lengthy topic, which we will cover in future. The third address is the 127.0.0.1. And this is the loopback address, which typically refers to your own machine. Whenever you see 127.0.0.1, you're actually referring to your own computer. So that means if you were to enter 127.0.0.1 into your web browser's address bar, you're actually trying to connect to your own computer. And unless you have a web server running, you will get a connection error. Now, there are some guidelines to how IP addresses can appear. The 4 numbers must be between 0 and 255, and the IP address of 0.0.0.0 and 255.255.255.255 are reserved and are not considered usable IP addresses. So IP addresses must be unique for each computer connected to the network. That means that if you have 2 computers on your network, each must have different IP addresses to be able to communicate with each other. So if by accident the same IP address is assigned to 2 computers, then those computers would have what is called an IP conflict and would not be able to communicate with one another. Now, IP addresses can be further broken down into classes. And these classes are appearing in front of you. That's A, B, C, D, E, and their possible ranges can go from 1.0.0.1 all the way to 254.255.255.255.254. Now, if you pay very careful attention to the table, you may just notice something. The range of IP addresses from class A to class B skips the 127.0.0.0 to 127.255.255.255.255 range. That is because this range is reserved for special addresses called the loopback addresses that I've already mentioned a bit earlier. Now, the rest of the classes are allocated to companies and organizations based upon the amount of IP addresses that they may need. So the address 0.0.0.0 is a special network and is generally used for routing. So let's chat a bit about each class, and let's start with class A. So from the table in front of you, you'll see that there are 126 class A networks. So these networks consist of over 16 million possible IP addresses that can be assigned to devices and computers. This type of allocation is generally given to very large networks, such as multinational companies. Next up, we also have is the loopback address, which I mentioned a bit earlier. So this is a special address, which is 127.0.0.0 network that is reserved as a loopback to your own computer. So these addresses are usually used for testing and debugging of programs and hardware. Now, on to Class B addressing. So this class consists of 16,384 individual networks, each allocation consisting of over 65,000 possible IP addresses. These blocks are generally allocated to internet service providers, ISPs, and large networks like a college or even a hospital. Next up, we have Class C. So there are a total of 2,097,152 Class C networks available, with each network consisting of 255 individual addresses. So this type of class is generally given to small to mid-sized companies. Now we have Class D. So Class D IP addresses in this class, they are reserved for for a service which is called multicast. Now we're nearing the end. That is, next up we have is Class E, and these IP addresses in this class are reserved for experimental use. And finally, we have what is called the broadcast address. This is a special network which is and the IP address for this broadcast address is 255.255.255.255, and is used for broadcasting messages to the entire network that your computer resides on. Now, there are also blocks of IP addresses that are set aside for internal private use for computers not directly connected to the internet. These IP addresses are not supposed to be routed through the internet, and most service providers will block the attempt to do so. So these IP addresses are used for internal use by company or home networks that need to use TCP IP but do not want to be directly visible on the internet. So the table in front of you lists these IP address ranges. So if you're on a home or office private network and you want to use TCP IP, you should assign your computers or devices IP addresses from one of these three ranges. That way, your router or firewall would be the only device with a true IP address, which makes your network more secure. So we chatted a bit about IP addresses and their function on the internet, and you can see it's an important concept to understand. So hopefully with this tutorial, we have a firmer grasp of this concept, which should help you troubleshoot problems and bring a better understanding of how the internet works. So now that you have a bit of insights and knowledge of IP addresses, let's take a look at TCP, UDP, and how they work with IP addresses. The devices and computers connected to the internet use a protocol called TCP/IP to communicate with each other. So when a computer in, let's say, Manchester wants to send a piece of data to a computer in New York, it must know the destination IP address that it would like to send the information to. That information is sent most often via two methods. That's UDP and TCP. So TCP stands for Transmission Control Protocol. Using this method, computer sending the data connects directly to the computer it is sending the data to and stays connected for the duration of the transfer. So with this method, the two computers can guarantee that the data has arrived safely and correctly, and then they disconnect from the connection. This method of transferring data tends to be quicker and also more reliable, but it puts a higher load on the computer as it has to monitor the connection and the data going across it. So let's look at a real-life comparison. So a real-life comparison to this method would be, let's say, to pick up a phone and call a friend. So you have a conversation, and then when it's over, you both hang up, and that typically releases the connection. That's TCP. So now that you have an overview of TCP, let's talk a little bit about UDP. Now, UDP stands for User Datagram Protocol. Now, using this method, the computer sending the data packages the information into a nice little package and then releases it into the network with the hopes that it will get to the right place. So what this means is that UDP does not connect directly to the receiving computer like TCP does, but instead it sends the data out and relies on the devices in between the sending computer and the receiving computer to get the data where it's supposed to go properly. This method of transmission does not provide any guarantee that the data you send will ever actually reach its destination. On the other hand, this method of transmission has a very low overhead and is therefore very popular to use for services that are not important to work on the first try. So comparison, you can use this method. The comparison we can use for this method is going to be the postal service. So you place your mail in the mailbox, and then you hope the postal service will get it to the correct location. Most of the time they do, but sometimes you can get lost along the way. So let's take a look at some of the more common TCP ports and protocols. Let's start with SMTP, or Simple Mail Transfer Protocol. So it is associated with the TCP port number 25. Now, the primary purpose of this protocol is to make sure that the email messages are communicated over the network securely. Not only does this protocol carry out the task of delivering messages within networks, it can also successfully deliver messages between different networks. Now, this makes it one of the most important ports for the communication of messages over the network due to the security it provides along with other features. However, you do not have the privilege to download the emails in order to read. It is just intended for the purpose of transferring them over the network. Next up is HTTP. So port 80 is associated with HTTP, otherwise known as Hypertext Transfer Protocol. It comes under the category of the TCP protocol. It's one of the most famous and widely used ports in the world. The main purpose of port 80 is to allow the browser to connect to the web pages on the internet. So port 80 basically expects or waits for the web client to ask for a connection. Once this connection has been made, you will get the privilege to connect to the World Wide Web and get access to various web pages out there. In fact, HTTP is one of the most important ports associated with the TCP protocol. Next up is HTTPS. So HTTPS is also associated with TCP protocol. Now, HTTPS, which is associated with port 443, also lets you connect to the internet by establishing a connection between the web pages and the browser. This lets you connect to the World Wide Web. However, this port has an added feature of security to it, which HTTP port 80 does not have. This port is intended for establishing secure connections to make sure that the data is transmitted over a secure network. The user receives a warning if the browser is trying to access a web page which is not secure. It basically encrypts and authenticates the network packets before transferring them over the network to increase the security. This feature of security is introduced by the use of SSL, which can be referred to as Secure Socket Layer. Now we have FTP. So FTP is the abbreviation of File Transfer Protocol. So the purpose of FTP is to transfer files over the internet. It basically lays down all the rules which are to be followed during the transfer of data. Due to the concern of security, it also asks for authentication by the user before the transfer of data. It is associated with the TCP protocol and corresponds to ports 20 and 21. The port 20 performs the task of forwarding and transferring of data. It takes over the task of transferring FTP data when it is in active mode. A port 21, on the other hand, performs the task of signaling for FTP. It listens to all of the commands and provides a flow of data. It is quite essential for maintaining the flow of data. Next up, we have Telnet. So Telnet, with Telnet port 23, comes under the category again of TCP protocols. So its main function is to establish a connection between a server and a remote computer. It establishes a connection once the authentication method has been approved. However, this port is not suitable to establish secure connections and does not cater to the concern of security. It enables the remote connection of a computer to be established with routers and switches as well. So it makes use of a virtual terminal protocol to make a connection with the server. Now we have IMAP. So IMAP is the abbreviation of Internet Message Access Protocol, and this operates on port 143. So IMAP 143 port lies under the category of TCP again. The primary purpose of this port is to retrieve emails from a remote server without having the need to download the email. So you have the liberty to access the emails from anywhere by connecting to the server and viewing your email and providing authentication. So this opportunity has been provided to you because of the existence of this port. It reserves a virtual memory for the email, which enables you to read it by connecting to the server. However, you may also download mail if you wish to do so. It also provides you the ability to search for your messages from a bunch of them to get to your desired one. Now, IMAP 143 port generally operates at the application layer of a TCP IP model. So, in addition to this, it also makes sure that the data remains secure during this connection. And now next up we have is RDP. So RDP is also known as Remote Desktop Protocol, and it operates on port 3389 of the TCP protocol. So this port has been developed by Microsoft. It enables you to establish a connection with a remote computer. With the help of this connection, you get the liberty to control the desktop of this remote computer. This will provide you with the ease to access your home desktop system from anywhere in the world just by proper authentication. In order to connect to your remote computer, you will have to forward the connection to TCP port 3389, which will then make available to you all the files which you have kept on your remote computer. However, since this port has been developed by Microsoft, it is essential to have a Windows operating system running on your computer in order to access it remotely. Please keep in mind that you might have to do some manual settings in order to remotely access your desktop using this port. It operates again on the application layer of the TCP IP model and is used worldwide for the purpose of accessing your desktop remotely. Now we have SSH. So SSH is also referred to as Secure Shell. It operates on port 22 of the TCP protocol, and it carries out the task of remotely connecting to a remote server or host. It allows you to execute a number of commands and move your files remotely as well. So it is one of the most secure ways of accessing your files remotely. So using this port, you can remotely connect to a computer and move your files with ease. This port sends the data over the network in an encrypted form, which adds an extra layer of security to it. In addition to this, only authorized people will be able to remotely log onto their systems using port 22, which makes sure that the information does not get into unauthorized hands. It provides a chance to move files within networks, as well as gives the privilege to move files between different networks securely. So this operates on the application layer of the TCP/IP model, and is considered one of the most secure and reliable ports for accessing files remotely. Next up, we have DNS. So DNS is referred to as Domain Name System. It operates on port 53 of TCP and UDP protocols. The DNS makes use of relational databases to link the host names of the computers or networks to their respective IP addresses. Port 53 waits for requests from DHCP to transfer the data over the network. Now, TCP protocol is used by the zone transfer function of the DNS server. Once a connection is established, the zone data will be sent by using the server using TCP 53 port. However, when the query has to be transferred from the client computer, it will be sent using the port 53 on the UDP protocol. If no response is received from the server within 5 seconds, the DNS query will be sent using port 53 of the TCP protocol. Next up is DHCP. So DHCP is also known as Dynamic Host Configuration Protocol. It basically runs on the UDP protocol. So the basic purpose of DHCP is to assign IP addresses, assign IP address related information to clients on the network automatically. So this information may comprise of a subnet mask, IP address, default gateway, etc. Many of the devices are automatically configured to look for IP addresses using DHCP when they connect to a network. It makes it quite reliable to assign all the devices on the network with automatically produced IP addresses. It generally operates on the application layer of the TCP/IP model, and DHCP basically makes use of 2 ports, port 67 and port 68. The UDP port 67 performs the task of accepting address requests from DHCP and sending the data to the server. While on the other hand, UDP port 68 performs the task of responding to all the requests of DHCP and forwarding the data to the client. Lastly, we have POP3. So POP3 is also referred to as Post Office Protocol version 3. It operates on port 110 of TCP protocol. It allows the email messages to be retrieved from the SMTP servers, and using this port, you can download the messages from the server and then read them. However, this means that you will not be able to access the messages and read them without downloading them. Furthermore, the messages are also deleted from the server once they are downloaded. However, this port does not cater to the issue of security. So the authentication details transferred over the network are not encrypted and are sent in plain text. This means that any hacker can easily intercept this information and misuse it. So port 110 generally operates on the application layer of the TCP/IP model. So we discussed some of the most common and widely used ports available today. We've seen how each of these ports are either related to the UDP protocol or TCP protocol. All of these ports perform different tasks and different purposes. While we have some ports where data can be sent securely, there are some others where transfer of data is more significant than its security. We can also combine different protocols and add the feature of security. So for example, SSL can be added to HTTPS port to add a feature of security to it. So considering the uses and applications of these ports, it's important to realize their significance in the process of transmission of data over a network. Not only do they help you to transfer data, they also let you enjoy some other facilities as well. In fact, it's not wrong to say that networking will not be complete without the existence of these TCP and UDP ports. And that is all for today. If you enjoyed this video, please be sure to leave a like, and also don't forget to subscribe to the IT Online Learning channel. Thanks so much for watching. I'll see you in the next one.